In this video, we will look at several ways of investigating motion. We will look at everyday objects such as toy cars or tennis balls. First, it is helpful to think about how we should approach investigations. When asked to describe an experiment, you need to consider four key questions. 1. What will you measure? 2. What will you use to make these measurements? 3. What will you do with your results? And 4. What can you do to improve the investigation? The first investigation we will apply this to is measuring the average speed. Number 1. Well, what will we measure? Well, to find speed, we need to measure the distance and the time. What will we use to make these measurements? Well, when measuring distance, we need to think about a piece of equipment that is correct for the distances being measured. Here we are measuring a distance of over 1 meter, so a tape measure is more appropriate than a ruler, for example. To measure time, we should use a stop clock. What will we do with our results? Well, we will use our measured values to calculate speed using the equation speed equals distance divided by time. To improve our investigation, we can repeat measurements, take an average, and this will improve reliability. It is important to say that we're going to take an average and why we are doing this, i.e. to improve reliability. Simply stating take repeats is not sufficient. In this investigation, we will also look at measuring speed, but this time we're going to use a ticker tape. A ticker tape is a thin strip of paper that passes through a ticker tape machine. We attach the ticker tape to the back of the trolley and feed it through the machine. The machine then punches dots on the paper every 0.2 seconds. So, if we know the distance between a set of dots and we know the total time, we can work out the speed. So let's look at an example. Imagine we have a ticker tape with dots evenly spread. This tells us the car is going at a constant speed, but more on that later. We can pick a pair of dots, the further apart the better. We know the interval between each dot is 0.2 seconds. So, for 5 intervals, we have a total time of 1 second. Measuring the distance between the dots with a ruler gives us a distance. So, for example, 8 centimeters or 0.08 meters. So, the speed of the trolley is distance divided by time, giving us a calculation of 0.08 meters divided by 1 second. So the speed is 0.08 meters per second. Different patterns of dots on the ticker tape tell us about the motion of the object. Constant spacing tells us the car is going at a constant speed. If the dots are further apart, the car is travelling faster. If the dots are getting further and further apart, then it tells us the car or the object must be speeding up or accelerating. If the objects are getting closer together, the object is slowing down or decelerating. It's worth noting that in the last two cases, if we were to perform the same calculation as we did on the previous slide, that is, counting the intervals to find the total time and measuring the distance between dots to find a speed, the speed we would have calculated would be an average speed, because the speed in these two cases is not constant. That's it for this video. In the next video, we will look at an example exam question for this specification point.